All right, in this section, 12.6, we're going to talk about solving exponential equations. We've talked about graphing, we've talked about application problems. Now let's talk about solving. If we get an equation with a variable in the exponent, an exponential equation, how can we actually solve them? Well, we can solve these exponential equations by using what we call the principle of exponential equality. Lots of big words, just meaning that if we have the base of two exponential quantities, if the bases are the same, well then the exponent should be the same. Let me show you an example. If I have 2 cubed equals 2 to the x, you notice that both of our bases are 2's, right? Well, if both of our bases are 2's, and if the equation says that the left side should be equal to the right side, well, if the bases are the same, then shouldn't the exponents be the same so that the left side equals the right side? So if the bases are equal here, then that means the exponent should be equal, and I can say that x equals 3. So as long as I can get my bases to be the same base, well then I can set my exponents equal to each other and figure out what x is. I can solve the exponential equation. Let's do a few. If you look at example number 1, it asks us to solve. We notice that we have a variable in our equation and it's up in that exponent, so we have a couple different exponential equations. We want to figure out what x equals. But if you notice on A, my bases aren't the same. The base of the left side is 4, and the base of my right side is really 16, right? 16 to the first power, it's just an invisible 1 there. So we need to somehow get our bases to be the same. Now we've got to be careful here. We don't want to change the value of my problem. We want to keep it the same value. So what we need to do is figure out what we can change our bases to. That'll be the same amount without changing the actual value of the problem. Well, I noticed that 16 could be changed into a base of 4, couldn't we? Instead of saying 16, could I say 16 is the same thing as 4 squared? Because 4 times 4 is 16. And so then I can write the equation 4 to the 3x is equal to 4 squared. I haven't changed any value. I've just rewritten 16 as a base of 4 to the power of 2. But if you look now, our bases are exactly the same. And since our bases are the same, then our property says that our exponent should be the same. So I should be able to say now that 3x is equal to 2. That now helps me get an equation that I can solve. I can divide both sides by 3, and I can say that x equals 2/3. Let's try another one. Look at B. I have 5 raised to the x minus 6 equal to 125. I want the bases to be the same, so I can start to figure out what x is. All right, 5 I can't really make into any smaller base. I can't break that down at all, but I can break down 125. I know that 125 breaks down to 5 and 25, and 25 breaks down into 5 and 5. So look at 1, 2, 3 5s. So instead of calling it 125, could I really call it 5 cubed? That's 5 times 5 times 5. Should give me a 125, right? And now my bases are the same. And as soon as my bases are the same, I know from our property that our exponent should be the same. So now I can say that x minus 6 should equal 3. I can now solve this equation by adding 6 to both sides. I ended up getting x equals 9. Remember, you can always double check your answers by taking your value and plugging it back into the original to double check. So let's try it real quick. 9 minus 6 is 3, and 5 cubed is 25. So I know I got the right answer, and it works.